Hi, I'm Ms. Fung. Let's have a look at maximum and minimum problems. Here we have example 1. A soccer player kicks the ball so that the equation of its path is y equals 1.5 plus x minus 0.02 x squared, where x is in meters and it's the horizontal distance, and y is also in meters but it's the vertical distance. Part A. Find the value of x for which the maximum height is reached. Verify that it is the maximum. So when we talk about maximum height, we look at when the gradient is 0. So dy dx is 0. We have y. To find dy dx, we differentiate. So differentiating y, we obtain, 1.5 disappears. X becomes 1, and negative 0.02 times the power 2 becomes negative 0.04, and x squared becomes x to the power 2 minus 1, which is just x. So letting that equal to 0 to find the maximum, we bring the negative 0.04 to one side, dividing both sides by 0.04, and we obtain x is equal to 25. Now, how do we show that it is the maximum? We put a table and we write down the x value, the gradient, and we draw the shape. So for the x value at 25, we know that the gradient is 0, and we know that the shape is flat. But what about just before and just after it? So just before would be 25 minus 1 is 24. Just after, it would be 25 plus 1 is 26. So now we calculate the gradient at 24 and the gradient at 26. So let's use a calculator to make that process a little bit easier. So let's type in the equation of the gradient, which is 1 minus 0.04x, and click Shift, comma, to bring out the vertical bar, which can also be found in Math 1, but this is just faster, Shift, comma. And then we let x equals, so we have to find the left of it, so 24, enter. And if you click enter again, you can just, it appears again, and you can just highlight the 24 and change that to the 26 that we want to find. And then enter again. Now we have both equations. Let me zoom in to show you. So see, if you hit enter, it repeats, and you can just highlight and change the value 26, and that will give you the value. So it's 0.04 and negative 0.04. So let's put that in. So let's put that information we found in there. So the gradient at 24 was positive, so it looks like this, and the gradient at 26 was negative, so it looks like this. So now we have that shape, we can see that it is a local maximum. So we put the statement, therefore x equals 25 is a local maximum. Part B, find the maximum height reached. Now the x value is the horizontal distance and the height was the y value. So now we have to find the y value. So y at x equals 25. Where do we put x25 into, the gradient or the original function? Well, for the y value, it's the original function. So let's do that. The original function, put x equals 25 in there, and we obtain y equals 14. Look at the question again, 14 meters. The maximum height reached is 14 meters. Example 2. A farmer wants to enclose the largest possible rectangle using a straight river as one boundary and 240 meters of fencing. What are the dimensions of the rectangle of the largest possible area? So again, largest possible area means stationary point, and we're looking at when the gradient is 0. So here we have the river. Let's draw it out so we can understand the question better. So when you're stuck, just try to draw and write down, simplify the information, and you'll probably see what you have to do next. So we have a river and we have 240 meters of fencing, and we want to make a rectangular boundary. So let's draw the rectangular boundary. Let's put in a value x for this length so that we can name the other lengths as well. So if this is x, then that side would also be x. And if these two are x's and we know the whole boundary is 240, then this section here must be 240 minus the two x's. Now, what are we looking for? The largest possible area. We know the area of a rectangle is length times width. So x times 240 minus 2x. And when we expanded, we obtained 240x minus 2x squared. And when we're looking at maximum area, we're differentiating it and letting it equal to 0. So differentiating that, we obtain 240x becomes 240, and minus 2 times 2 is minus 4, and x to the power of 2 minus 1 is 1. So letting that equal to 0, we bring the 4x to the left, dividing both sides by 4, we obtain 60. So x is 60, but is that a maximum area? Let's prove it using the table just like we did in question 1. So x equals to 60 is a gradient of 0, which is a shape that is flat. And then we go to the left and to the right. So to the left of 60 is 59, to the right of 60 is 61. And we find the gradient. So I used the calculator to find this bit and plugging in 240 minus 4x and finding what it is at x equals 59, which is 4, which is positive. And at x equals to 61, it is negative 4, which is negative. So we can see that it is a local maximum. Have we answered the question? Just check. What are the dimensions? So we found one side. Now we have to find the other side as well. 240 minus 2x, where x is 60, plug it in and we can see that the length is 120. So the dimensions of the rectangle of the largest possible area are 120 by 60 meters. Example 3. If the volume of water V liters in a hot water tank T minutes after the shower is turned on, it's given by the rule Vt equals 200 minus 1.2 T squared plus 0.08 T cubed, where T is between 0 and 15. Part A, find the time when the volume is at its minimum, that is the length of time the shower is on for. So when we say minimum, we say dV dt equals to 0. So let's find dV dt. So if that's V, then the 200 disappeared, minus 1.2 t squared becomes minus 2.4 t to the power of 1. And then 0.08 t cubed becomes 0.08 times 3 is 0.24. And t cubed becomes t squared. And we let that equal to 0. And we can see that we can factorize by taking 2.4 t out, and we do so, and we obtained 2.4 t, 0.1 t, because when you multiply it you get 2.24 t squared. And I've just swapped them around so the positive is to the left, and then minus 1. 2.4 t times minus 1 was that is negative 2.4 t. So now we have that, we see that t is equal to 0 and t is equal to 1 divided by 0.1, which is 10. Now we know that the time taken to take a shower has to be greater than 0, and therefore t equals 10. Remember to put this line in so that you give reason why you're not using one of the values or you obtain. So part B, verify that the minimum, verify that it is a minimum by checking the sign of the derivative. What does that mean? Put a table in, put t, the gradient, and the shape. So t equals 10, we have the gradient 0, shape is flat. To verify if it's a minimum, we go to the left and the right again. To the left is 9, to right is 11, and we plug it into this equation, the gradient. And for when t is equal to 9, we obtain minus 2.16. So use a calculator for this part. And then it's negative. And when we put in 11, we see that it is 2.64, which is positive. So we do have a minimum. Now, part C, find the minimum volume. So the minimum volume happens when the time is 10, because that's what we worked it out to be. So V of 10. So V of 10 means we're plugging into this original equation, and we can use a CAD calculator to see that it's 160. And reading the question, 160 liters is the minimum amount of water. Thank you for watching, and I'll see you next time. Bye!